conversation she'd often contend. Costumes build customs that evolved at end.
Hello and welcome to the video on related rates. So first of all, what are related rates? So an overview of these kinds of questions, a big overview. So something to keep in mind is that what is the goal of these related rates? So our goal, for the most part, for all of these questions is to calculate or to find an unknown rate. Find an unknown, some kind of rate of change. Okay, so unknown rate of change by being resourceful, really, by using other, and I'll abbreviate rates of change, or rate of changes, that we do know, or we can find out very easily, or not easily, but so that we do, I can't think and talk at the same time, so that we do know, and I'll underline that, so that we do know or can find out, and those other rates of change are somehow related to the one in question, and are somehow related, hence related rates, right, are somehow related to the one in question, the one that we are trying to find. Okay? So I think that the best way to explain, other than like this whole conceptual like overview thing, so I think that one of the best ways to explain things and to teach things are by showing you through an example. So we're going to start with the classic. It's called the falling ladder, or the sliding ladder. So the falling ladder, aka sliding ladder. Okay, so what is this? So the setup for this is basically we're saying that, okay, so here's a ladder, all right, okay, this is not going to turn out. Usually they just draw like a line. But anyway, so I'll do two lines for you guys. So here's our ladder. I'm sorry if it does not pictorially look like a ladder. I admit that. But anyway, so this is a ladder, all right? And it's leaning up against a wall, okay? And the bottom part is obviously resting on the floor. Okay, so here's the wall and there's the floor. And what it's doing, so let's say, I'll give you a number, so 25 feet long. So let's say this ladder here is 25 feet long, okay? So 25 this way and this way. All right, so 25-foot long ladder. This is what a problem would look like. Is leaning up against, I'll just say against a wall, and sliding down at a rate. So here they'll give you a rate, or sliding down, period. Okay, so the base, the bottom, right? So the base moves away from the wall, at 3 feet per second. Okay, so that's what they give you, and they're asking how fast is the top sliding down? The top of the ladder that's touching the wall, how fast is it sliding down? Okay, and then they'll tell you, or they could also add in, so how fast is the top sliding down when, sorry, this is a crucial part, when the bottom is 15 feet from the wall. Okay, so a lot of information here, and I probably won't be able to copy this down every single time, otherwise this video is going to turn out being like 45 minutes long or something like that. So anyways, let's go through and dissect what the problem is saying. So it's saying that this ladder here, okay, so it's leaning against the wall, right? So it starts off here at some point, and then it's going to slide down, right? So the top is sliding down, and at the same time, simultaneously, the bottom is sliding out at a rate of 3 feet per second. Okay, and the question is asking how fast, so what is this rate over here, the rate of this arrow? How fast is it sliding down when the bottom is a certain distance away from the wall? Okay, so let's go into more detail and see how to actually approach this problem. So I'll give you guys a few steps on how to go through it. So first of all, the first step I'm going to list is to, number one, draw a picture. Even if you are not an artist, then I would still advise to draw a picture. Even if you dislike drawing, I would suggest drawing a picture, especially for these related rates, okay? It's often really helpful, even for me, to draw the picture just to get a visual of like what's going on and how are certain rates from the problem related to the other ones. So what's pictorially going on. Okay, so the first thing is to draw our picture, so I'm going to draw a picture. This time I'm not going to make double lines for the ladder because on the previous slide that didn't turn out so well. So anyway, so here's our ladder, right? We know that I'm going to label these sides. So the second step, so here's our picture. This is the ladder, this is the wall alongside, and this is the ground. Okay, so there's our picture. It doesn't have to be super fancy or anything. Step number two is to label this picture with variables, and fill in the values of what you know. So fill in what you know or are given. Okay. So first of all, let's label these with variables. So I'll label the sides A, this is B, and the hypotenuse is C. Okay. And then we're going to also, label with variables and fill in what you know. So along with variables, I would also suggest label with rates too. So these variables aren't only of like the sides of our triangle in this case, so we're going to also add in and rates. So the left side here, this is dA dt, because in this problem we're dealing with time, right? So dC dt, how is C changing with time? And lastly, dB dt, how is this length here changing with time? Okay, so we're going to fill in what we know. So C, we know that the length of the ladder is 25 feet. So we do know that. That's good. Also, from the previous slide, so I'll write down what we were given. So 25 feet is the length of the ladder. We know that we're trying to find this rate here, dA dt, how fast is it sliding down as the bottom is sliding away? How fast is it sliding down? So we're trying to find dA dt. We don't know A, okay? We know B? And yes, we do know B because we are given that we're trying to find the rate dA dt when the bottom here is 15 feet away. So 15 feet away from the wall. Okay, so 15 feet is equal to our B. That's what we're given in the problem at the very end of our problem. What else were we given? That the rate of the base sliding away is 3 feet per second. Okay, so we can label that in our picture. All right, let's see what else do we have. So we have the B's are covered. We have B equals 15 feet. dB dt is 3 feet per second. Let's look at the C's. So we have our C is 25 feet. dC dt, so how is the length of C changing with respect to time? So this ladder, we can assume, if it's not a crazy weird ladder, that its length is going to remain constant. So that means that this 25 is always going to be 25, no matter if it's leaned up against the wall or if it's down flat on the ground. So this dC dt is going to be 0 feet per second. Okay? And then the last thing, so we're trying to find dA dt, right? dA dt is our unknown. dA dt equals, I don't know. So this, we just identified, this is step number 3, is identify the unknown. Okay? So unknown. All right? So we don't know dA dt. This is what we're trying to find. And as well, along with that, we don't know A either. We don't know the length or the height of the from the floor to the top of the ladder at this time, right? So we don't know these two things. Okay, so let's see if we can narrow it down so that we only have one of these still being a question mark. Okay, so we'll do so on the next slide.